On the agenda for today, we're going to talk about initializing variables to 0. We're going to talk about redirecting standard out and piping to standard in. We're going to talk about replacing things in strings a little bit more, and hopefully, if we have time, we'll do it in class assignment. So first thing I want to talk about is initializing variables to 0. So I wrongly told you that variables are 0 by default. So that actually turns out it's not the case. So you always need to make sure that your variables are set to 0, otherwise they might contain garbage. Now, more times than not, they are going to be set to 0, but in a lot of cases they aren't actually going to be set to 0. So, looking at this example, we have alexsucks.c. So what this does is...
Remember when you peeked on my assignments and you saw one about Carter?
So what this does is declares 1,000 variables and it prints the value of each of them. So you can see that we get a bunch of warnings because when I put the compiler in strict mode, it does notify you when it's uninitialized, so you should notice when you haven't set anything to 0 or used it before. But if we go ahead and run this program, so we see that a bunch of these variables are 0, and we scroll up a ways, and they're still 0 and 0 and 0. But after a while, we do notice that a bunch of our variables are just random garbage numbers. And this is because they weren't assigned to 0. But it's also worth noting that more times than not, well, I guess not necessarily, but a good number of those times you will get 0. It's more likely that you'll get 0 than anything else, but if you want to be sure that you have a number that's starting with 0, you definitely need to make sure that you set it equal to 0 when you start using it. So this example just uses individual variables. This also applies to arrays. So when you make an array, remember that you need to so we have an array of 10. If you want that array to be set to 0, you need to say equals bracket 0. And this will set the entire array to 0. So also remember that if you're working with an array that you set the size on runtime, so remember we can have a variable like size equal to 10, and then we set our array to that variable size. Normally we could change that size based on user input, but if we did something like this, we can't do something like this and set it equal to 0 all at once. We can't do this. This doesn't work. Remember that if we dynamically size our arrays, we need to use something like init. So remember the init function we wrote a bunch of times earlier. Just loops through every single element of the array and sets that each element of the array equal to 0. So you can look back in other code that we've written to look at that. But essentially what you would do is just call init, you pass an array, you pass in how big it is, and you pass in what you want each element to be set to. So keep that in mind. You need to set variables. Let's say we're using int count. We need to set that equal to 0. And whatever other variables we're using, we need to set equal to 0. Unless the very first time we use them, we set them to something somewhere else. So let's say we're using like half. And then we have a for loop, which goes from I equals 0, I is less than size plus I. And inside this for loop, we would say half equals right away. So the first time we use half, we set it to something. Like let's say half equals size divided by 2. If the first time we use it, we set it to something, we don't necessarily have to set it to 0 at the beginning. But we can't do something like this and say array at position half and expect that to be 0, because that's not necessarily going to be the case. It will lead to behavior that's very hard to debug, so it's just the best if you just set your variables equal to 0 when you first use them. So sorry I didn't cover that more in depth earlier. I was under the impression that everything was by default 0, so I was set, or somebody corrected me in my opinion. So that was setting variables equal to 0. Any questions about that? So next thing I want to talk about today is the ctype functions. So one of the things we've been doing a little bit when we've been working with strings is we've been manually writing conditions to determine whether or not a letter is uppercase or lowercase, or a bunch of other things. But C actually provides a bunch of different functions for us to use, and they're all defined in ctype.h. So in order to use them, we would go include ctype.h. So just another header file like any other. I'll also include stdio so we can print stuff out. So looking at a couple of these, so these functions return 1 if the condition specified is true and 0 if it's false. So like is alphanumeric is the first one. So if the character is lowercase a to lowercase z, uppercase a to uppercase z, or 0 through 9, it will return true. Otherwise, it will return false. So is alpha, that will return if the character is a through z, uppercase or lowercase. Digit 0 through 9. Graph, if the character is anything other than a space or a tab. If lower, it will return true if it's a lowercase. If it's printable, there's a couple characters which aren't printable in C. Don't worry about that one too much. So is punctuation, it will return true if the character is a symbol, space, if it's a space, a tab, or a new line, and is upper will return true if it's an uppercase letter, and is hexadecimal digit if it's a hexadecimal digit. So a hexadecimal digit, it's another way to encode numbers. So instead of saying 0 through 9, we'd say 0 through F. Not necessarily important that you know that right now, but something to keep in mind. And there's also 2 character conversion functions provided in ctype.h. There's 2 upper, or 2 lower and 2 upper. So it converts a uppercase letter to a lowercase letter and an uppercase letter to a lowercase letter. So let's look at those a little bit. So we'll just have a result variable, and we'll just say res equals is upper, and we'll just pass in a. So this should return 1. So let's print off the result. There's no, it's all lowercase, that's what's happening. Wow, I guess it returns 256. But let's see what happens if we put in lowercase a instead. This should return 0. Yeah, so that returns 0. So, doesn't necessarily return 1 and 0 if it's true or false, but remember that non-zero is true and 0 is false. So if we put something like if res print f is uppercase, so remember that if it's non-zero, it's true, and 0, it's false. So right now this is going to be false, but if we change this to a, that will end up being true because 256 is not 0, so it's true. So capital A is in fact uppercase. So we can take this down a little bit, and instead of assigning that result somewhere, we can say, or we can put a function call directly inside of our if statement. So we can say is uppercase, and then pass in A right there. So not uppercase, just upper. So capital A is uppercase. So you can use any of these functions inside your if statements to determine whether a character is uppercase or not, or whatever other comparison you want. So let's say we had an array of characters, and we had ASDF. So we can also reference regular characters. We can say str at position 0. That will result in A. So str at position 0 is A, which is not uppercase. So nothing's printed. So we can also convert letters from lowercase to uppercase and uppercase to lowercase. So what we can do is, let's say we wanted to replace, let's say we want to capitalize the first letter of str. What we would do is say str at position 0 equals to upper str at position 0. And then we'll just, we'll print out str really quick. So you can see that that function capitalized the first letter. So same thing with lowercase. We can use toLower if we want to convert something from uppercase to lowercase. And we can use these functions without writing all the logic. You don't have to use these functions, but they do provide an easy way to manipulate strings. So I'm going to go through and I'm going to do a couple more string replacement manipulation examples. So replacing a target n number of times, so truncating a sentence to a single word, and capitalizing the first letter of each word. So I think I had something, yeah. No, that was our assignment. It was scanfs. So we had this function character replace from Monday. And what it does is it loops through and it searches to see if the string at the position in the for loop equals a target, then we're going to set the string at I to the replacement. So let's change this up a little bit and let's change it to, say, int count. So, or int limit, let's call it. So what we're going to do in this loop is we're going to only replace limit number of times. So we're going to need another variable called count to count the number of times we replaced something so far. So we could say count equals 0. And then every time that we replace something, we increment count by 1. So one of the things we need to do is we only want to replace something if the string equals the target and the limit is less, or the count is less than limit. So going back over here, let's say we wanted to, we're going to change this up a little bit, and we're going to char replace. So str is what we read into with fgetAs. str, so we're reading in 10. So our target, let's just target A, and we'll replace it with Z, and we'll do that a maximum of 1 time. Missed a semicolon there. So we'll say A. So we can see that this function only replaced the first A because we limited it to 1 replacement. So going back, we can change this. We can have more than 1 replacement, of course. We can do, let's just do 3 for right now. And it will replace each occurrence of A up until a maximum of 3 times. So that's just an example of some more in-depth character replacement we can do. So just counting how many times we've done a replacement, and then if the count or if the limit has been exceeded. So as soon as count is equal to limit, or anything above limit, then it will stop replacing characters. So that was the first example. The second example is truncating a sentence to a single word. So let's say we enter a sentence here. We will just comment this out for now. So remember that one of the problems we have with scanf is that we can with scanf we can use scanf to allow the user to input a single word. So when we use scanf with the %s, we can read in a single word from the user. So I'll actually go back, and I'll show you that really quick. So we have a character array. Let's just give it size 10 for right now. And then we say scanf %s and then str. And then we'll use puts to just output it really quick. So hello, sup. So we can see that scanf only accepted one word. Now, like I talked about on Monday, scanf and gets aren't necessarily secure because they allow the user to input any number of characters. So I can input characters way above 10. So I'll just try and get this to crash again like I did before, just by putting in a bunch of A's. So theoretically, this should segmentation fault. Because what happens is again, it overrides other components of the program because we exceeded the number of positions in the array. So what we can do is we can actually use fgetS to get a single word. But we also want to make sure that the user isn't allowed to enter any more than one single word. So going back here, so let's just compile that again. So ASDF. So let's say we wanted to limit this to be one single word. What we can do is we can replace any occurrences of spaces with the null terminator so that our string is immediately terminated. So we search for space, we replace with \0 for the null terminator, and we want to do it a maximum of one time. So you can see now when I'm inputting more than one word, our program replaces this space with null, or \0, and it will immediately stop printing when it encounters that \0. So that's it for truncating a sentence to a single word. And then finally, I want to talk about capitalizing the first letter of each word. So what we'll do is we'll write a new function called void sentence case. It will take a character array or string like that and the size of the string. So we'll just loop from 0 I equals 0 to I, well, from 0 to size, and then we'll increment I. And then what we'll need to do is write a couple different if statements. So the first condition we want to target, so if I is equal to 0, because the first character always needs to be uppercase regardless of where it occurs. The second case is if str at position I minus 1 equals space. So what this does is get the character before our current character and check to see if it was equal to space, and then that's all the conditions that we need. So we would say if one of these conditions is true, we would say str at position I equals I think it's 2 upper str at position I. And this contains all the logic needed to capitalize the first letter of every single word. So I'm going to comment out this, because remember what this does is only allows us to enter one word, or it doesn't allow it. It modifies the character array so that only one word is printed. So going back, we would say sentence case str size. In this case, I also need to set size equal to 10 because I didn't do that before. And I also need to include ctype.h when I'm using that toUpper function. So we can see that both letters of the words in the sentence are capitalized. So one thing I want to test really quick, I don't remember if this works or not. Yeah, so if they're already capitalized, they'll just remain capitalized. So that's just another example of string manipulation. So for the, oh shoot, I forgot to cover one thing. So the other thing I want to talk about was redirecting standard out and piping to standard in. So one of the things you can do when you're running your program and you want to store the output of the program, we can say a.out and then use the use this character right here to redirect the output of your program to a file. So we can say program name and then whatever this character is. I don't remember what it is, and then give a file name where you want the output to be stored. So I'll just call my output file output, and then we'll just put ASDF again. And you can see that nothing was outputted to the terminal. So instead of being outputted to the terminal, it was actually outputted to a file, in this case output. So if we open up output, we can see that the output that we expected to be outputted to the terminal was instead outputted to this file. So we don't have to say output. We can say res or something like that. So the program will still accept input from the user, but all of the printfs, puts, things like that you call will instead be redirected to this file. So again, I'll say ASDF, and I'll open up res. And the output that we would expect to be outputted to the terminal is instead in this file called res. So pretty simple, but it's kind of useful if you want to keep a track of what output you have. So there's actually another way we can do this that's a little more extensible. So let's say we just want to duplicate the output from our program. Instead of using that character, we can instead use the pipe character and then say t and then the file name that we want it outputted to. So we'll say res again. So what this will do is it will still output the output of your, it'll still print the output from your program to the terminal, but it will also write it to the file. So ASDF, it will print it to the terminal, but if I open up res, it will also be stored in this file. So use that if you want to preserve the output to the terminal, but also write it to a file. So that's redirecting and piping to, or piping from, standard out. The other thing we can do is, let's say we want to provide input to our program from a file. So let's create a file called input, and we'll just put ASDF in. And then what we can use is we can use a program called cat. So what cat does is it takes a file and it echoes it to the terminal. So whatever the contents of the file are, it will simply put it into the terminal. So what we can do is we can say cat input and then the pipe and then a.out. And what this will do is it will take the contents of this input file and it will essentially emulate the terminal and provide those contents of the file instead of the user input. So when I push enter, it immediately runs and immediately gives us our result. So one thing to think about, so this is, again, this symbol is called a pipe, and this would be called a redirection symbol. So when a program's on the left and is being piped to something on the right, it will redirect the standard output. So when I say standard output, I mean when we use printf inputs to output to the terminal, that's what we consider standard output. But when the program's on the left, or when the program that we're running is on the right, sorry, and is accepting something from the left, it will input it to standard input, which we read from with scanf, gets, fgetS, and all those functions. So we can put multiple programs in our pipeline, as they'd call it, because we're using pipes. So we cat reads from input, it forwards that to the standard input of our program, and then our program forwards the output to, let's say T again, and we'll say output. So again, what T does is it still outputs to standard out, but it also outputs to the file. So what T does is it duplicates between the terminal and the file. So just kind of an example of how you work with standard in, standard out. If you want to redirect things, you want to write to a file without actually writing to a file, because this is all managed by the user. Later on in 250, you'll talk about how you'd actually programmatically write to a file. So that's all I had for you today, but I would like you to work on this in-class assignment. So what I want you to do is read in 4 strings from a file. So cat a file and redirect it to standard in, and then print those strings in a random order. So, and then submit to day 34 in class. So any questions about this or assignment 7? Feel free to ask.